So I decided I'm gonna reopen the homework just for tonight, in case I missed it. But that's it. I'm not gonna get into the habit of extending the homework. But I gave you plenty of time, way past the test. It is, I think, unfair or to ask for more time at this point. So, but I'll do this one time. I got a few emails from people who missed it, so just gonna do it again. Okay, logarithmic functions. So starting right after we wrote those properties. So we're gonna test the properties and see how they work and talk about what does it mean, what does the logarithm mean exactly. And it helps to write through this example here. I tried to put it in words for you, but it sounded super weird. So I think that this will help. We said whenever you read this statement, right? Just pretend we knew the answer, or whatever. What this is saying is, what is the power that I will raise 2 to get 8? That answer is 3. Does that make sense? Raising 2 to the 3rd power to get 8. That's basically what I said in words at the end of last class on Friday. Remember I had the sentence. That's what that meant. Okay, the definition. So you can rewrite this using the definition we wrote last time as 2 to the 3rd equal to 8. So this is the base, right? 2 and 2, the power 3, and the number in question 8. Okay, so it's very dyslexic, so be careful. Just remember the definition we wrote. Okay, so the first few homework problems are going to be like, all right, here's a log, change it to exponential, or here's an exponential, change to log. Okay. Do another one. So log base 5 of x equal to r. So change that to exponential form. Can't draw arrows. 5 is the base, right? 5. The power is what it's equal to. And equal to the argument. Okay, so just remember that formula if you can. If you don't have that memorized, it's fine. Just have that definition with you. Okay. Now, those are straightforward because it's already set up. If you see one of these, you have to simplify it first. Because technically we know that the base is 2. We're going to go from exponential to log this time. So I know for sure it's going to have a log of 2. But the power is kind of weird, so we have to fix it. So remember we said in the rules of exponents, you bring it down and change it to positive sign, right? The power. This is a 5, that's a 5. My attempt at 5. These are 2s.
What's about 3?
Yes. Negative 3, 5. Okay. So 2 cubed is 1 over 8, right? So now that we know what the actual argument is, let's change it. So we have log base 2 of 1 over 8 equal to negative 3. So the power is negative 3. The base is 2. The argument inside is 1 over 8. Okay. Anyway, we're just applying the definition. There's not much else to really do. We just have to look at the definition, change. That's it. I've got to write the title here. This is a change XP to log or vice versa. Sorry about that. Example 2. Example 2. Apply the properties of logs. So the ones that we wrote last time, just have them handy, or hopefully you remember them. Applying properties of logarithms. Part A. So we said that no matter what base you have, if there's a 1 inside, it's always going to be 0. So this is always true. So it's log 57, and there's a 1 there, it's going to be 0. Doesn't matter what it is, always going to be 0. I don't care what's down. So this property right here was this one. Log base of A, so any base of 1 is equal to 0, where A has to be greater than 0 and not equal to 1.
Is that log 57?
Yeah. As long as there's a 1 in there, 0. Okay. And then we also wrote down a property that said if the base, I'm gonna stop using 5. Log base 6 of 6 to the 7th power. We said if the bases match the arguments, they're going to cancel, leaving you only with the power. So this property was log A of A to the X, we said in the notes. This will be X. So the first 2 homework problems are going to be just this. Can you convert back and forth? And then they'll have some random property where you have to simplify. You're not solving for anything. You're just simplifying stuff and practicing with the properties. That's it. It's like a weird Sudoku game. Nobody cares about. Any questions so far? Is it all right?
It was so bad. Like yesterday? Yeah, I didn't see it. Yeah. I said last night. Yeah, I'm good then. It's so bad.
It's 7 to the log 7. So this is
Yeah.
the opposite direction. So if they match like this, it's going to be the same situation as C.
I know. It would be great.
So that rule was this guy here, this one. A raised to the log A of X is equal to X. Some of these as well. There will be some where you have to simplify. So let me add those real quick before I move on, just in case you get stuck. So if you have something like this, log base 2 of 8, you have to first simplify the 8. You're going to get log base 2 of 2 cubed. So your goal is to match the 2, match the base. So you rewrite the 8. 2 cubed is 8, right? So they cancel. So I use this property here. So the simplification will require you to do some algebra and then apply the rule. Okay. So you have some of those. Or you might have one like this. It's a little harder. Before I move on, any questions on C, D, or example 3? You guys cool on these? No rush.
Okay, so the 127, is that the same thing we did on the top one C? We had to switch it over because it was a negative?
Kind of, yeah. Pretty with similar idea. We're about to use that, yeah. Because if we first switch to the 3 cubed, right? You see how 27 is 3 cubed. then we bring it up top on purpose, so the bases will match. Like, that's what we're gonna do, pretty much like we did C, but in reverse. So this is 1/3 cubed, right? That becomes 3 to the -3. And now they match up. Property takes effect. There we go. -3. Any questions on 3 or 4?
That last, on example 4,
Mhm.
log 3, 3 to the -3 equals -3.
Yes. Yeah, so the 3 and the log 3 cancel, which is this property here from Friday. I think it was property 3 or 4, I think. Anyway, any other questions? Make sense? So you may have to do a little extra work to apply the properties or simplify. But the entire time is just you're just simplifying stuff, practicing with these rules. The whole point is to practice the rules. That's it. Let's do one more that's strange, and then we'll move on to something else. Log of square root of 10. Now, if they do not write a base, it's assumed to be 10, right? That's called the common log. So the one in your calculator, you have 2 of them, unless you have a really fancy calculator. See, there's a log button there. That's base 10. As soon as you use it, the base 10. If you were to use the ln one, this button, that's base e, which we'll talk about later. So there is no base, 3 on there. So this right here is actually base 10. So there's a 10 in there and it's base 10, so they should cancel once you do a little bit of work. So change the root, change it to a power, that's what you gotta do. So you agree that this is the same as 1/2 power. So now the base matches the argument. So they will cancel out. Any questions on 3, 4, or 5?
No. That is very-
So here's log base 2 of x. Just gonna give you a graph just so you know how they look like. Here we go. They basically look like the diminishing returns graph. You guys remember diminishing returns from economics? You guys take economics yet? It's just a basic concept. It's nothing fancy. The easiest way to explain it, I would say, let's say you're trying to hire people to paint a fence, right? If you hire one guy, it'll take X amount of time. If I hire 2 people, intuitively we think it should be done twice as fast, right? But if I hire 100 people, will everyone be working in the fence? Probably not, right? I mean, maybe it's a giant fence, maybe, but let's assume it's your house or whatever, a basic size fence. So basically, the more resources we add, the less return we get. That's diminishing returns on our investment, right? So the graph looks like that curve. All log curves do. So base 2, if I plug in a 2, that I said we're going to get if I plug in a 1, so we're going to get a 0. But plug in a 2, we are going to get 1. So it has this kind of shape. It starts to kind of level off pretty quick. Probably has a better level off. I think that's 2 exponential. Something like this. Okay. So it grows kind of fast at the beginning. When I get those 1, 2, or 3 painters. After that, there's no difference in rate. I'm sure there's better examples. That's all I can think of spur of the moment. And we're not going to go into economics. That's not this class. But in case you were curious. Okay, let me give you a better looking graph. That's the shape. As you can see, it levels up pretty good. And it is the inverse of an exponential graph. So if it's base 2 to the x, it is the complete opposite, the inverse of log base 2 of x. If you were to compose them together, you would get cancellation of just the x arguments. Okay. Anyway, that's what the logs look like. So all I want you to remember is what is the general shape here. That's it. You might be asked to graph something really basic. Probably not on a test though. I don't really care about graphing on exams too much. You guys cool on this page? Right. Natural log definition, and then we'll be done with the section. The logarithm with base e is called the natural logarithm. And is defined by the following. So the logarithm with base e is called the natural logarithm and is defined by this. The log base e of x is the natural log, which we use ln x as a notation. So whenever you see ln, we're talking about base e. Okay, it's assumed to be e on your calculator and on all math books. Okay. And if you were to use the definition on this guy, ln x equal to y, we would get a transformation to the exponential e to the y equals x. Right. Homework 7 through 47 odd. You guys cool on 4.3? The main thing I want you to know is the basic properties and what does a log look like. Main thing. Four point four. Laws of logarithms. So for your next exam, I'm gonna focus for chapter 4. It's gonna be over chapter 4 and 5, by the way. I'm mainly gonna focus on 4.4 and 4.5. Maybe, I don't know if it'll be 4 or 6, but the last couple of sections, focus there. I have a little bit from the beginning, but not too much. But we'll talk about that way later. Let A be a positive number where A is greater than 0, little a is not equal to 1, and capital A, B, C are real numbers where A is greater than 0 and B is greater than 0. So all that needs to be true for the following properties. Will A be a positive number where A is greater than 0, not equal to 1, capital A, B, C are real numbers where A is greater than 0 and B is greater than 0. So the product rule is rule number 1, or law 1. Log base A of A times B is going to equal a sum of A and B. So if you have a product, change it to sum. If you have a sum, you can go to product, okay? Number 2, quotient rule. If you have a quotient, A divided by B, that will equal a difference of A and B. Shoot, that should be base A. Sorry about that. All the A's must remain the same. They don't change. When you apply these laws, it should be the same base. Okay, number 3, if your log has a power, which we'll use C for that, log base A of capital A to the C, you can bring down the C, or you can bring it up if you want. That'll be the power rule. Got to write power on top. Okay, so if you have C, bring down. If it's in front already, you can bring it up if you choose. Evaluate the following. I'm going to use numbers to start out with, and then we'll use just variables. Example 1, log base 4 of 2 plus log base 4 of 32. So we have a sum, right? So we're going to use rule 1. So right away, you will see that this is going to be log base 4 of 2 times 32, which is a log of 64. So from here to here, we use rule 1. So now the question becomes, can you simplify like we did in 4.3? Can I turn this into a 4? Right, 64 is 4 times 4 is 16, times 4 is 64, right? So 3/4. So this is 4 cubed. So they match. So that would be simplified as far as you can. So apply the rule 1 and then simplify the number. Any questions on example 1? It's okay. Okay, part B, let's try another one. Log base 2 of 80 minus log base 2 of 5. So if I have a difference, you will divide it, right? What is 80 divided by 5? 16.
Oh, so, okay, adding your times in is subtraction in the line.
Yes. Yeah, that's what rule 1 is the times, rule 2 is the division one. So by rule 2, this happened. And then by your algebra, this turns into 16. Then the question becomes, can you rewrite this as a power of 2? How many 2s is 16?
4.
4. They match. So that's it. That's the property from 4.3. So we use at the end. Any question on A or B?
I was taught, I want to say I was taught that there's like sort of an order of operation. You always want to do power rule first or last.
Yeah, once we start, yeah, we're talking about that real soon, but yes, when we're combining logs together into one single log, you want to make sure there's no numbers in front. So you got to bring the powers up first. Yeah, that's true. You are remembering correct. Any other questions on A or B? Yes, cool. Okay. I haven't added the videos from last time. I will very soon. So for those of you that got here later. Okay. Example 2. So let's practice expanding the logs and then combine it, and then we'll stop there for today. Expanding logarithmic expressions. I wrote that super messy. Very sorry. Believe it or not, I practiced a ton trying to write better as a kid. Didn't take. Wrote like spirals and spirals. But no, still write like my doctor in school. Log base 2 of 6x. So expand as far as you can. This is 6 times an x, right? So separate it into a sum of 6 plus the x. Right, so that's by rule 1. Now, technically 6, I'll write that a little better. Technically that 6 has 2 factors, right? What is the factors of 6? So you can break it up further and then apply the rule again. So let's do that. that make sense? So now do it one more time. This will become log base 2 of 2 plus log 2 of 3 plus the last piece there. And then these match, right? Technically. That becomes a 1. And then that's it. Nothing else to do here. Don't forget, we're not solving for anything. We're playing a game, I guess. Any questions on any of those steps? Do you see what we did on the first, second, etc.?
What's it by zero?
By 1, I'm trying to quote the rules so you know what we did. So I used number 1 and number 1 here by changing the product to sum. Any other questions? Okay, let's do another one. This one's a little harder. Log base, don't use 5, let's say 3. Log base 3 of x cubed y to the 6. So we have two pieces, right? Products. X cubed times by 6, so apply it there. Log base 3 on both, of course. You can put the power outside or in, doesn't matter to me. So by number 1, we did that. Then we can bring the powers down. So you have to go as far as you can. By 3. That was rule 3, the power rule. So you can bring them down whenever you want, bring them up. So in the homework problem where they ask you to expand, you're gonna go as far as you can. So bring all the powers down, get all the sums, all the pieces. That's as far as you can. Any questions on B? That make sense? Just remember, if there's a times, change it to plus. That's it. Okay. You guys cool on B then?
So when there's a divide, and you change the subtraction, you're gonna opposite.
Yes. Yeah, let's do one of those. Let's do both at the same time. Let's say there's an A times B on top and a cube root of C down here. And the instructions are expand as far as you can. I will for sure give you one of these on the exam. The instruction will be expand. So notice that there's a bunch of things going on at the same time, right? So when you see a big fraction like this, just do the division first. So the whole top part minus the whole bottom part. Like who cares what's in there? Just top minus the bottom. Like this. That makes sense? By rule 2. So don't try to do it all at once. I mean, you can. Just be careful, but I recommend do it like this. That way you won't mess up the signs or the simplification part. This was on top. This was on the bottom. Now apply the product rule on that first part. And I think that's almost everything. That C has a cube root. So what kind of power is that? So that was by rule 1. Final step, what do we do? Yeah, that's it. by rule 3. Okay, so first step was separate the fraction. Second step was separate that product. Last step, bring down the power. So there's nothing else we can do. Any questions on part C? Okay. So homework will start off with basic numbers. Then we'll start to get to stuff like this. Okay. Little by little. You guys cool on this page? Okay. All right, let's talk about combining logs now. And that'll be our last example. So it has multiple parts though. I recommend you practice these log rules before next time, so the next part will make more sense. But it's your life. Do what you want. Okay, so 3 log x plus 1/2 log x plus 1. Combine as far as you can. So as we were saying earlier, right? You have to first bring those powers up. We have to apply rule 3. So it's basically the reverse of what we did earlier, because it is exactly the opposite. So bring them all to 1 log is the goal. First thing is apply rule 3. Rule 1 right there. Then we can simply use rule, sorry, that was the 3. Now we use rule 1. So this will become x cubed times x plus 1 to the 1/2. You can change it to a square root if you want to, but that's also fine. Same thing, right? Okay. Any question on part A? Seem doable? Okay. I mean, you've done it before in college algebra, so I'm hoping you remember a lot of it. If not, you've got plenty of time to practice, right? Now, notice I didn't put parentheses this time. Does that matter?
No, but it makes it easier to read.
Yeah. So don't let them bother. Don't let it bother you. Feel free to put parentheses. Technically, they should have absolute value bars, but it depends on how you define the variable. Like in the book, they might have ln of absolute value x, because you cannot have negative values inside your logarithm. But if they define the variable to be positive, then you don't need them. But you can put parentheses if you want. It's all good. So what is the first thing we do? Yeah, let's do the power rule. Make some space. This will be ln of x cubed plus ln of y to the 1/2. Do I bring up the -4 or just the 4? Doesn't matter. Either way is fine. But if you do the negative, you'll create an extra step. I mean, it's up to you again. It's your life. I say just bring up the 4 by itself. But both work. You bring it negative, you just put a plus there and that's fine. All right, so we did from here to here, rule 3. So now I recommend you do this piece by piece, so 2 at a time, apply your rules, so you don't make a mistake, okay? You don't have to do it this way. Again, it's just a recommendation. You don't have to do it my way. As long as you do follow the math rules, you'll be good. So that was by rule 1. We combine the sum into a product. Now we have 2 terms with a minus. So this garbage goes on top, right, of the fraction. This garbage goes on the bottom. This is the denominator and numerator. We're going to have ln of a bunch of stuff. This top part over this bottom part. Any questions on part B? Any of the steps? Is it okay? All right. I'm going to give you a formula. I'll probably give you one of these on the exam as well, but it's a question that I hope is a give me question, meaning it's a free points. Don't miss this question. So log b of x, this is the formula change of base. Technically, the formula is given a base b and an argument x, you can change to any base that you choose. Doesn't matter, you pick it. But of course, it must be positive, right? Those rules are still there, the restriction. Base must be greater than 0 and not 1. But let's say you wanted a specific base that would be helpful. This goes here. This base goes here. So the A right there is the one that you choose. I can change any base of some argument to whatever I want, as long as I put the argument and the base in those parts. Does that make sense? The book,
Log
yes.
A or log B?
They're both A's. So this A is the one that you choose. The B is some base you start with. Okay. The book only writes this one. So you just use ln. Now, they do that because if you have a really weird base that's not on your calculator, change to ln, which is a simple button on your calculator. That's why they do that. So if I give you something like on a test, what's log 2 of 7, change it to this, and you give me a decimal number. So that would really require almost no work. Don't miss that guy, please. A must be greater than, well, actually both. Make a note here. A, B, and x must be greater than 0. A and B are not equal to 1. Man, I'm sure that was already implied, just in case. There it is. So let's write down that example I mentioned. So on a test, they give you something like this. Log 2 of 7. Use your change of base formula. Punch it in your machine, which will give you 2.8 something. I think it's this, yeah. This goes on forever. That makes sense? So this is the question I meant. That's 3 points, please don't miss it. The easiest one. 4.4. Homework is 9 through 59. This one will be a little longer than the rest because these rules are important for you to be comfortable with. Without being comfortable with the rules, you can't do the next couple of sections. And again, like I said, the majority of the test will be the later section of chapter 4 for the chapter 4 material. I will stop here. Do you guys have any questions on 4.4?